in the Algebra Refresher packet, starting with number 19. Write an inequality to model the situation. So I see Carson went to the carnival with $30 in his wallet, $12 in food. Rides cost $2.50 each. That each is a clue that that number is going to get multiplied by the variable. So if I'm going to write an inequality, I know he's got $30 and he can't spend more than $30, so the amount that he spends has to be less than or equal to the $30. He spent $12 on food, so we know we have $12 spent, and then on top of that he's spending $2.50 on each ride. So $2.50 for every ride. So I'm going to say that R is the number of rides. So this is my inequality. What is the most amount of rides that he can ride and not borrow any money? So I want to solve for R. So I'm going to subtract 12. And then divide 18 divided by 2.5. And that is, I'm going to take out my calculator, take 18 divided by 2.5. And so R is less than or equal to 7.2. Well, he can't go on 0.2 rides, so the most rides he can go on, it would be 7 rides. So Carson can go on at most 7 rides. Number 20. Solve by substitution. Substitution is we have to make sure that one of the equations is solved for one of the variables. The first equation has y by itself. So I want to substitute this expression in place of y. Since y equals 2x plus 7, I'm going to put it in place of y in the other equation. That's going to give me 3x minus 2. And now in parentheses, I'm going to insert the 2x plus 7. And that's going to equal negative 13. Now I've got an equation with just x, so I'm solving for x. Distribute the minus 2 to get minus 4x minus 14. Combine 3x minus 4x is negative 1x. Add the 14 to the other side to get positive 1. Divide by negative 1. X equals negative 1. So now I'm going to insert that negative 1 back into this equation that was solved for y. So y equals 2 times negative 1 plus 7. Negative 2 plus 7 is 5. So my solution is negative 1, 5. It's always a good idea to plug those numbers back in to make sure that they work. 3 times negative 1 minus 2 times 5. Does that equal negative 13? Yes, it does. Okay. Number 21, solve by elimination. Elimination is where we want to add the two equations together to cancel out one of the variables. Right now, if I add them together, neither variable cancels out. So I have to multiply. 5 and 3 both go into 15, 2 and 7 go into 14. That's a little bit smaller, so I'm going to use that one. So to get negative 14, I need to multiply the top equation times 7. To get positive 14, I'm going to multiply everything in the bottom equation by 2. So 5x times 7, 35x. 7 times minus 2y is minus 14y. 16 times 7 is 112. Then we take the second equation, 3x times 2 is 6x, 7y times 2 is 14y, negative 15 times 2 is negative 30. So as I add these equations together, 35x plus 6x is 41x, negative 14y plus 14y is 0, 112 plus negative 30 is 82. So 41x equals 82, divide by 41. 82 divided by 41 is 2. So now I take that value of x and plug it back into one of these equations to find y. I'm going to choose the second one. So I'm going to take 3, insert 2 for x, plus 7y equals negative 15. 6 plus 7y equals negative 15. Subtract 6 to get negative 21. Divided by 7, y equals negative 3. So my solution is 2, negative 3. Check that by plugging it back into the other one. 5 times 2 minus 2 times negative 3, and that does equal 16. Number 22. So in a system of equations, we're looking for an x and a y value that are the same, that are true for, that are solutions for both equations. And so when we're looking at a table, I want to find where the y values are the same for that same x value. So the first equation has the point 4, 7, and the second equation has the point 4, 7. So once you find where the y values are the same, we're going to write the x coordinate 4 and the y coordinate 7. That is a solution to both equations. Number 23, solving by graphing. So to graph this first inequality, I might find it easier to solve for y first. So I'm going to subtract 2x and then divide everything by 3. So 15 divided by 3 and negative 2x divided by 3. This means that I have a slope of negative 2/3 and a y-intercept of 5. So I plot 5 on the y-axis, go down 2, right 3, down 2, right 3. So less than, so that means a dashed line, not less than or equal to. Make sure I get that dashed line. And its y is less than, so I'm shading down from that line. The second inequality has a y-intercept of negative 3 and a slope of positive 2, up 2, right 1, up 2, right 1, or down 2, left 1. This one is greater than or equal to, because it's equal to, it's a solid line. Its y is greater than, so I'm shading up from that line. And so the place where it's below the dashed line but above the solid line is the section here to the on the left side of the graph. Okay. Number 24. So I see the absolute value sign, so I know I'm going to have a V shape to the graph. This is x minus h plus k, and so my h and k are positive 4 and negative 2. So that's the vertex. Positive 4, negative 2. The a value is 1, So that means my slope is up 1 over 1. And make the V shape, so I reflect that to go the opposite direction. And its y is greater than, so there's no equal to, therefore it's a dashed line. Y is greater than means I'm shading above that, or inside the V. Y is less than or equal to 2. This means that it does not have, since it does not have an x, it only crosses the y-axis. So this is a horizontal line that has a y-intercept of 2. Horizontal line, because it's less than or equal to, the equal to means it's a solid line that crosses the y-axis at 2. Y is less than or equal to means I'm shading below that line. So below the horizontal line but inside the V, that means I'm looking at this inside section of the graph. (25) and 26 say define two variables and write a system of equations. Do not solve. So my question is asking in 25 how many adults and how many children. So I need a variable for adults. A equals number of adults, and C equals number of children. So I've defined my variables. Now write a system of equations. So a system means more than one. So there's 12 people that went to the holiday concert. Some of them were adults, some were children. So if I take the number of adults, A, and add to that the number of children, C, that needs to equal the total number of people, 12. Then looking at the dollar amounts, it's $18 for adults. So 18 times the number of adults is how much money is spent on the adult tickets. And on top of that, they spent $10 for every child. So 10 times the number of children gives you the amount of money spent on children. So the amount spent on adults plus the amount spent on children needs to equal the total amount, 192. We do not need to solve, so we go on to 26. The question is asking, what are the dimensions of the rectangle? So in a rectangle, I have a length and a width. So I'm going to make L, I use a cursive L, for the length of the rectangle, and W for the width of the rectangle. The perimeter is 36 feet. Well, I find perimeter by adding length plus width plus length plus width, the distance around the outside. So I had 2 of the lengths plus 2 of the widths need to add up to the total perimeter, 36. The second sentence looks like I can translate it directly into symbols. The length, L, is equals 2 feet longer than. Any of these phrases that have the word than in it means kind of reverse the order. So longer means I'm increasing it by more than. So 2 feet more than means I need to add 2 onto 3 times its width. 3 times the width. So the length is 2 feet longer than 3 times the width. That is the system of equations.